Crash barriers for roads and bridges are among Bieste's most important products. The development of a new barrier is a comprehensive process that requires extensive resources. All our products must meet the requirements of European standards, as well as the exacting demands of our customers. We have the expertise and the capacity to develop an idea into a finished product that is crash-safe and that complies with the customer's wishes according to applicable norms. Before our products are launched on the market, they must first be approved through the use of authentic crash tests. By first testing the products in virtual simulations and then on our own test course, we can minimize the time required during the development phase. Knowing that an idea is feasible even before we start to manufacture the prototype saves both time and resources. The close proximity of the test course to the production facility also contributes to reduced delivery times. We can help with the development and production of a barrier for a specific project, which enhances the possibilities for architects and designers to develop customized solutions. Here at Bieste, the path to a new barrier begins with an idea that is drawn up and for which calculations are performed. The barrier is first tested by way of virtual simulations before we manufacture a prototype. The computer simulations often show the exact outcome of an authentic crash test. We can gain a preview of how the vehicle moves and how deformed the barrier and the vehicle become during a collision. In this way, we can improve and assure the quality of the product before we manufacture the prototype. After that, it's time to perform a pre-test of the product in our own test environment. In order to match the international competition and to have full control over the development of our own products, Bieste has invested in the development of our own test course. The course is designed to be able to test a barrier up to and including the higher H4 capacity classes. Prior to each crash test, the barrier to be tested is assembled in concrete or gravel. A crash test must ensure that persons inside the vehicle are not subjected to an abnormally high level of impact when the vehicle crashes into the barrier. Advanced digital measuring equipment is assembled inside the vehicle to measure the level of impact that the driver and passengers are subjected to at the point of collision. The vehicle is brought up to the right speed with the help of a traction device. A cable on the ground with a control device ensures that the vehicle remains on the right course prior to impact with the barrier being tested. The crash barrier shown in the film is being tested for capacity class H3, the second highest class provided for by the standard. A number of high-speed cameras are assembled at different angles to document the crash and to illustrate how the barrier and the vehicle perform during the crash. The H3 class stipulates that the barrier should be able to withstand a crash test involving a 16-ton vehicle at a speed of at least 80 km/h, colliding with the barrier at a 20-degree angle. The same barrier should also be able to withstand a collision with a 900-kilogram car at 100 km/h at a 20-degree angle. We assembled a 100-meter-long barrier prior to the test in question. With the help of lines at different distances behind the barrier, we can see how much the barrier buckles during the crash test. The barrier needs to be soft enough for the lighter car, yet strong enough for the heavier truck. When the product is fully developed, a further test must be carried out, this time under the supervision of the regulatory authority. They check that our tests comply with the prescribed rules and that all the instruments are correctly calibrated and that everything is documented correctly, in order that our test results can be deemed comparable with those from other tests and that the barrier can be approved for use.